Hello and welcome to our webinar today, How to Build Scalable Web Applications in the Cloud, Reference Architectures and Best Practices. Before we get started, we're actually going to launch a couple polls to get a couple bits of feedback from you, our audience. So let's get started with the first one. We'd like to know if you're using cloud infrastructure today. So that would be infrastructure as a service tools such as Amazon's EC2 or Rackspace. So just choose one. Let us know if you're already up in the cloud with one or more applications in production, if you're just getting started, maybe you're beginning to explore, or no, you don't have plans for cloud at this time. So we'll just leave this open for a couple more seconds. And let's look at what you guys had to say. Okay, cool. So that's interesting. There's a really good mix of folks who have varying levels of cloud experience, so that's great. Let's go to the next one. Have you ever deployed a web application on the cloud? So yes, you have deployed a web app on the cloud. No, you've not deployed a web app on the cloud, but you have deployed one in a hosting facility. Maybe you've deployed one in-house, or if you've never deployed a web app, you can go ahead and choose that last option. So this is helping us understand kind of your experience with deploying web applications. Leave this open for a couple more seconds. Wow, that's really exciting. A lot of you have deployed a web app on the cloud. Very cool. And then there's a good mix between the hosting facility, not so much in-house, and some of you have never deployed one, so hopefully you are interested in learning how. Let's do the last poll. So just so we can get an understanding of where you're at currently, do you have a web application project? So yes, maybe you have one that you're trying to find a solution for today. Maybe you're beginning to explore, or no, you don't currently have a project, but you're still interested in learning. So let's leave this open for a couple more seconds. Cool, a lot of you have a project that you're trying to find a solution for today. That today was supposed to be on the end, it looks like it cut off. Cool, thanks so much for your time and your feedback. Let's get started with the webinar. So I have with me today Michael Crandell, RightScale's CEO and founder. I also have with me here Brian Adler, RightScale's Senior Professional Services Architect. Brian helps large customers migrate to the cloud, and he's also designed new applications that run in the cloud using cloud architecture. So he's our in-house expert on developing these cloud reference architectures. I also have on our Q&A line Jared Hensel, Account Manager. So Jared will be answering your questions throughout the course of the webinar via the GoToWebinar questions panel. So just anytime you have a question about anything that's come up, anything that's on your mind, feel free to enter that in there, and Jared will help you out with an answer. He'll also be monitoring that and pushing out the ones that are more generally applicable, and Michael and Brian will answer those live on the air. So just again, go ahead, ask any questions at any time. And with that, Michael, I will pass it off to you.
Thanks, Sarah. Thank you, everybody. Greetings, welcome. Thanks for spending some time with us today. Wanted to say a word at the beginning about why we're doing this webinar. We're doing the webinar on scalable web applications because it's really one of the most common use cases that we have seen that companies look to deploy in the cloud. So it's a very, very common use case, and we've decided to, so much so that we're actually very close to publishing a white paper that was authored by Brian, who's sitting here with me, on how to do this, and we thought we'd also do a webinar. This webinar is designed to go into quite a bit of detail technically on how we recommend architecting these web applications and what the various options are. So we'll dive in today into what we've put here, the what's, whys, whens, and hows of scalable web apps. We'll walk through a comparison of more traditional ways of models of building web applications and then how to do it in the cloud. From a best practice point of view in our experience. We will present a reference architecture. So this is appropriate both for those of you who are hands-on trying to design applications for the cloud or have already done it, scalable web apps, and also those of you who might be in a position to make decisions about architecture, whether it's purchasing decisions, approvals, etc. So we'll go into quite a bit of technical detail here, as well as covering best practices for each tier of the reference architecture. And then we'll do some wrap-up and allow time for Q&A at the end. And once again, as a reminder, please feel free to ask questions anywhere along the way. So the gentleman who's sitting next to me here, Brian Adler, is a person who has been intimately involved with the design and architecture of these scalable web apps at RightScale. He's a person, if you were signing up as a customer, that you might well be talking to. And so some of the material he's covering is kind of a condensed course of what might be reviewed if you were coming to us and signing up right away. In the spirit of openness, we like to share content-rich presentations. So we're going to share with you a summary of what we might cover with a brand new customer. With that, Brian, take it away.
Thank you very much, Michael, and thank you also to Sarah as well. And as Sarah mentioned early on, I am an architect in our professional services organization. And in that role, I've been involved with a lot of customers from the small startups all the way up through the enterprise corporations. And as a result, I've had the fortunate experience to be exposed to quite a few different web applications, architectures, and need and use cases. And as Michael said, what we're going to talk about today is sort of the lessons that we've learned and the tips and tricks and techniques that we've accumulated through those engagements. Before we delve into the nitty-gritty details, though, I did want to kind of set the stage a bit with sort of the whats and the whys and the whens and the hows, as Michael had alluded to. So for the purpose of this discussion, what we're going to be calling a scalable web app is an application built on an architecture that it can adapt to changing conditions. The important thing to note here is that both the application and the architecture need to be able to adapt. They need to be dynamic. You can have the greatest architecture in place, but if your application can't take advantage of it, well, you're not really going to be able to scale. So we'll talk as we get a little bit further into the webinar this morning about some of these details. Why? Why do you need to do this? Well, traffic and load patterns are unpredictable. Anybody out there that has a web application that has experienced any sort of unforeseen traffic event, you got a mention on Slashdot or Dig, or a Twitter post drove a lot of traffic to your site, something like that. These viral and flash mob events can cause some really spiky traffic, some dynamic and unpredictable traffic patterns. So you want to be prepared to handle that. You also want it for availability and reliability. You want your application to be there when your customers need to get to it. So in order to accomplish that, we'll talk about some of the architecture details that you can use to make that happen. And then also we'll talk a little bit about the traditional hardware model and the cloud model, and sort of the two classic cases before the cloud model came to be was to over-provision, throw a bunch of resources at a problem and basically be underutilizing them when you didn't need them, or to under-provision and basically handle the normal case and not be ready for this spiky traffic. And the next two slides pictorially represent that, and since I blatantly stole them from one of Michael's presentations, I figure I better let the boss talk to him. So.
Well, this under-provisioning is, sometimes we call it the success disaster, where you're so successful that you create a problem. I think most of us by now are quite familiar with this problem, but it's a great graphic to represent the situation we're in. The yellow line is anyone's best guess at the infrastructure, the demand that will drive infrastructure need into the future, so you make a guess there. The blue line is, of course, in a traditional sort of pre-cloud world, what you have to do for provisioning in steps. So we buy hardware infrastructure, usually in tranches. So every so often there's a flat line, then it goes up, and another flat line. And in this diagram, the red curve is actual demand. And you can see it's kind of squirrely and unpredictable there. So it puts us in the situation of either having overspent, represented by the opportunity cost arrow there, the green arrow, where we've overspent and we have too much capacity. I think those who have been in this game for a while know that the typical prediction method was to guess your maximum demand and then double that in terms of capacity, at least double it. So it was just so hard to guess that people were regularly doing a 2x kind of over-provision. But worse yet is where you guess wrong on the other side and you under-provision. And again, whether those customers are experiencing a slow website or a crashed website, you've got big dissatisfaction occurring. So what cloud has enabled is really this kind of holy grail situation where infrastructure can dynamically scale to meet needs, and so that's what you see here, where the blue line much more closely matches the red demand line, and where the system is automatically adapting by scaling up or down resources based on automated trigger actions. So let's dive into the mechanics of that. Brian, this is the graph that represents the architecture you're going to show us, so let's dive in.
Exactly. Thank you, Michael. And as Michael just alluded to, the reference architecture that sort of going to assist us through the rest of this webinar is depicted here on the slide you're seeing now. I'll spend just a minute making sure this is clear to everyone, because we will be referring back to it, or at least tiers within it or components within it, throughout the remainder of the session. Probably doesn't look that unfamiliar to a lot of you out there that may have deployed applications in the cloud in particular, and even in data centers. But basic gist is that you have load balancing tier, and that can be accomplished via a couple different mechanisms, which we'll talk about in a moment. Then behind that, you have your application server tier. And what we've drawn here is, in this particular case, there's two persistent or non-transient servers, which are depicted by App Server 1 and App Server 2. Those two will always be there. But the app servers you see in the yellow box, 3 through N, that's the scalable part of the scalable application, right? So that's where we're going to be adding and removing servers as demand dictates. And we'll delve into all the details around that in a moment as well. Behind that, then you see the caching tier. And that tier is there basically to help out the database, right? That's to relieve some of the load and improve the performance and increase the livelihood, if you will, of the database that you guys have set up in your web application. And then lastly, behind that, the last tier is the database tier. And what I've depicted here is sort of the classic scenario, which is the master-slave. But there are other options that we'll delve into as well at the end of the webinar. And then at the bottom you see S3. That can be S3 or whatever your cloud's particular flavor of persistent redundant storage is, and that's obviously where you want all of your database backups to go. And again, we will talk about that as well. So with that said, I'm going to start at the top and slowly work our way down to the bottom. Okay, the load balancing tier. All right, there's several different options, but there's basically two main ones that the majority of our customers use. And I'll talk about them here in turn. The first one is HA Proxy with Apache in the mix. The nice thing about this is that you can handle SSL termination on the load balancer with the Apache component there. You can also run HA Proxy by itself without Apache if you don't need that SSL termination. But the vast majority of the customers that we get involved with either need SSL or envision needing it in the future. So it's good to plan ahead and have it in place so it doesn't have to be something you need to patch in at a later date. The nice thing about HA Proxy as well is that it's always had, for many versions, a status web page. You can basically connect up to that web page and get a sort of real-time feed on connection status, how many connections have been attempted, how many have failed, what the back-end distribution is to your application servers, things like that. And with version 1.3 and higher, which is supported within the RightScale platform, there's also a server stat socket that you can connect up to. So you can programmatically connect up to that socket and suck down all that data on the connections and do whatever that is you might need to. You can have that fed into a separate system, or you can implement your own type of dashboard type war room scenario where you can watch that traffic. The nice thing about HA Proxy is that each instance can handle a specific amount of traffic with no ramp-up time. Basically, it can go from 0 to max instantaneously without worrying about dropping any connections. Now, the downside of that is each instance can only handle that specific amount of traffic. So if you're going to be spilling over what a single or double HA Proxy solution can handle, you need to add additional load balancers. And we recommend always over-provisioning at the beginning because addition of load balancers is possible, but it does require some DNS modifications. You need to add those new HA Proxy boxes in, modify your DNS records, etc. So it can be done, but it is a manual process, and therefore we generally recommend over-provisioning. And that's a common theme that you'll hear through the rest of this presentation as well. The second solution that a lot of our customers use is the Elastic Load Balancer. And those who are familiar with the AWS offerings, you'll be familiar with the ELB. Since mid-October of this year, they have supported SSL termination. The really great thing about the ELB is that it can scale to handle large amounts of traffic. Basically, we threw a bunch of traffic at it. We're able to get it handling over 20,000 requests per second. Now, granted, it took a little bit of time for it to get there, so slow ramp-up time may be an issue for you. We always recommend testing and see if which of these solutions is correct for you. However, there are options that exist for pre-warming that ELB, basically getting it ready if you know that you have a big event coming up. And if you have questions about that, that's something that the folks here at RightScale can help you out with. Nice thing is you only need one. It will scale to accommodate the load. Now, granted, it is basically a load balancing appliance, so when you're adding one appliance. How it's implemented behind the scenes is not really one instance per se, but it does appear to outward vision as a single appliance. Now, the only downside to that is you don't have visibility into those inner workings. So you can't look at connection rates. You can't look at statistics on your failure rates or the distribution of your back-end servers, things like that. But some of our customers don't care, and that's something that needs to be made on an individual basis. If you really want to dig into the details on the tech side and know exactly what's going on behind the scenes, HA Proxy may be a better solution. If you don't need or care to worry about all that, then ELB is probably a viable solution as well. And you'll see at the end, so I think the last slide or so has details on where you can get a lot of these white papers, in particular the load balancing one. And as you see there, it's at rightscale.com/whitepapers. One thing that you'll see on our website is you'll see mention of a load balancer plus an application server and what we call our classic 4-server architecture. And while this is definitely possible and good for test and development, we don't recommend it as a best practice for a production environment, because if you do get spiky traffic, if you do have some unforeseen event, well, now all of a sudden you can have a load balancer / application server that's doing neither of them very well, right? So it really makes sense to separate out your tiers so that you can address any particular need case at the individual tier that's suffering the problem, as opposed to trying to solve a problem that involves multiple components at once. What's our recommendation? Well, if you're not using the ELB, for example, and we recommend a minimum of 2 load balancers. And each load balancer should be in a different availability zone, and that's to help increase the reliability and availability of your solution. And through the testing that we've done and that you can get access to in that white paper, we've shown that the AWS instance size M1 large is a pretty good choice for load balancing. There's sort of a speed of light issue with packets per second through the virtual interface on AWS's EC2 infrastructure of about 100,000 to 120,000 packets per second. So really you've maxed that out on M1 large, and throwing a larger instance size, such as an M1 extra large or any of the M2s for that matter, don't really have that much of a performance gain, because you're not CPU or memory limited. You're basically interface limited at that point. And we've tested and found that roughly 5,000 responses per second can be handled by one of these M1 larges. So what we generally recommend is figure out what your worst case or best case, however you want to look at it, where you have the most traffic coming in, divide that by 5,000, and that's roughly the number of HA proxy boxes you need to throw in there. And we always recommend throwing in additional ones just to handle that unexpected under-provisioning event that we had talked about earlier. Okay, so that's the load balancing tier. What we're going to delve into next is work our way down the stack. We're going to talk about the application server tier. And as you see here, this is the part that really puts the scalable in your scalable application, right? This is where you add the application servers to help handle the load that's coming in and being load balanced by those front-end servers. So, autoscaling. What do we mean by it? I want to talk a little bit about it. It's probably fairly obvious, but we want to make sure we get into all the details on it. What we mean by that is a fully automated server launch based on some auto-scaling triggers. You want these servers to become operational with no manual intervention. They need to be able to be triggered to boot up. They come up, they join the load balancing pool, and they start contributing with no manual intervention. Therefore, it's important to download and install your application code from some common repository, because you want to make sure that all of the application servers are identical to their siblings. You don't want to have version A of code on one set and version B on a second. And we'll talk a little bit later about how to accomplish that as well and make sure that your code versions are consistent. The triggers that I talked about, and what we mean by the triggers are, what is it that causes me to scale up and what is it that causes me to scale down? Well, we have the common set and the ones that are provided with the RightScale platform. And those are things like CPU idle. Basically, if the CPU is not that idle, send me some help. If the CPU is not very idle, you can take away some of my help. Free memory, that's typical in a lot of Java applications sometimes. And then system load. Folks are familiar with the load.midterm value. That's a very common one to use for autoscaling triggers as well. We can also provide custom metrics in the RightScale platform using what we call our collectd plugins. And those are things like web server connections or any application-specific metric that you may have. If your application can be queried to spit out a number, that number can be used to scale both up and down. Speaking of scaling, when to scale? Well, we always recommend you do it conservatively, both up and down. And what do we mean by that? Well, in the up direction, you want to allow adequate lead time for those servers to become operational, right? It takes a few minutes to launch a Linux server and a little bit longer than that to launch a Windows server. So you want to make sure that you have accounted for that time that it takes for those servers to completely boot up and become operational. You want to account for that in your auto-scaling triggers. You want to do this before the system is negatively impacted, right? You don't want to be reactive. You want to be proactive. You want to look for trends and react early, right? And what's the worst can happen if you end out scaling too soon, right? You charge for an extra instance hour. So in the grand scheme of things, it's a very low cost to pay for that safety and security net. In the down direction, same concept. When the system has been underutilized for a consistent, consecutive period of time, you don't want to deal with just particular spikes in lulls, but you want to make sure that it's a consistent lull. Generally, we recommend that you scale down fewer servers than you do in a scale-up event, unless you're doing a one-to-one. Sometimes in small websites, when they're first getting started, they scale up by 1 and they scale down by 1. But a lot of our larger customers may scale up by 10 or 20, and maybe in the downward direction, they scale down by 50 or 60% of that. Again, the downside is that you might pay for a little bit of extra time, but the next hour that comes around, those servers will be torn down. Again, we recommend that it's better to be safe than sorry. It's okay to spend that extra 34 cents an hour or whatever it was for that server to make sure that you have the capacity available. Okay, we're now going to talk about the array, the area you see there in the yellow box on the slide on the screen. And that's the scalable part. And we'll talk about what the considerations you want for that scalable part of your application tier. What we always recommend is that you weight the array across all availability zones. Notice I say they're not regions, right? And for example, those of you who are familiar with EC2, there's US East, US West, Asia Pacific, and EU. Each of those regions has multiple availability zones. We always recommend that you weight across the availability zones within the region that you've selected. That increases the reliability of your application. The important notes there are, as well, is that traffic within the availability zones on the private IPs is free. If you do traffic between availability zones, there's a per gigabyte charge. It's fairly nominal. I believe it's currently a cent per gigabyte, but it is something you at least want to be aware of. And traffic between regions is charged at the public internet rate, so you're dealing both with cost and latency. So we've seen very few cross-region deployments. There are some, but it's definitely the exception and not the rule. We recommend you set your minimums and maximums appropriately. You can set a minimum size on your array and a maximum size on your array. The minimum can assist in cost savings when you have some lulls in activity. Maybe you have a social game and it's typically only played during daylight hours. Maybe you put an array minimum of 1 so that there's some insomniacs out there playing at 2 a.m. They have at least a server available for them to get onto. And the maximum can limit your overall cost exposure. So if you have some crazy scaling event that goes out of hand, you can put a limit on the actual infrastructure costs that you're going to incur by saying, I don't want my array to grow above this certain size. Speaking of size, the instance sizes. We typically recommend in EC2 that an M1 large for these application servers, it's a pretty good building block to work with. But M1 smalls and even micro instances can be used in test and development environments to kind of help you nail down the specifics of your architecture. Every application is different. You're going to hear this again and again, so we recommend running load tests, right? Run your load tests and find these benchmarks and help yourself find what the optimal solution is for your particular environment. And then as far as code deployment, we talked about earlier about making sure that all the application servers in the tier have the same version of code. Well, within the RightScale platform, we have the ability to run a script across all servers in an array that allow you to deploy that code. So with a single click of a button, you can go ahead and check out a brand new version of code and be sure that all the application servers in that array are going to run that script and therefore download that exact same version of code. Okay, with that said, we're going to move one more tier further down in the stack. And we'll start to talk about the caching tier. And caching can, as you see here, can dramatically decrease the load on the database, obviously particularly in read-intensive apps. There's not as big a gain in write-intensive apps, but if you have a read-intensive application, typically you can gain quite a bit of performance and prolong the life of the database before you need to re-architect the database by making good use of caching. Now there are some costs of caching as well. There is application complexity, and you have to modify your app. Instead of the old school, the application goes to the database, well, now it goes to the caching server. If it's not there, it goes to the database, it puts it in the caching server, and then continues on its merry way. So you do need to make modifications to your application, but they are fairly minimal and self-contained. And then obviously there's the additional instance hours to support the cache. You're running additional servers out there to implement your cache, so there is obviously the cost to keep those servers up and running. So the recommended best practice is to have a separate and dedicated caching tier. Now, you can implement cache on each application server, and some of our customers have done this. Basically, their PHP code, for example, is co-resident with memcached. However, this really prevents the use of a distributed cache because you don't want to use this solution in a distributed cache because servers will be joining and leaving that caching pool, which will cause quite a bit of database degradation as the database tries to reshuffle the data objects consistently. So if you do use a solution such as this, that cache should only be used by the co-resident application server and not by any other servers in the tier. The instance size and count. How big and how many should I use for my caching tier, right? Well, what we generally recommend is determine your overall application memory caching footprint. Let's say that it's going to be 30 gigabytes as an example. Well, that would be sufficient. You could use 4 or probably 5 M1 larges would suffice for your entire application, your entire caching tier. So what we recommend is maybe over-provision that. Instead of using 5, use 7 or 8, something like that, to make sure that you have full coverage of the entire caching needs of your application and to give yourself some room to grow. Now, this prevents the loss of an entire cache. You don't want to have all of your cache on a single instance. You could use an M2 Quad XL, for example, which has 68 gig of RAM, which is more than enough, more than likely. But if that one server goes down, your entire cache goes down. So we always recommend you distribute those servers across multiple servers and in multiple availability zones, again, for reliability. And as I touched on a moment ago, over-provision if possible. You want to provide that capacity that you need now, plus some room to grow. And manually scaling caching servers is possible, but it's a non-trivial endeavor. You basically have to do some application and database performance degradation. You have to modify your app to inform them of the new caching servers, and there'll be some database degradation as the objects are reshuffled. And but occasionally you do need to add new servers, or servers go down, you need to replace them, and that's why we recommend on the time to live, you always want to set your time to lives to expire. You can set them to indefinite, where they never expire, but in that case, if you had a reshuffling of objects, you may have an object be persistent on a server that'll never be accessed, yet it's sitting there in memory, taking up memory. We talked a little bit about write-intensive applications, and these don't see as large performance gain as read-intensive apps, but there are some tips and tricks that we can help you with if you guys have questions about write-intensive applications. But generally, caching is recommended. Most applications are heavily read-intensive compared to write, so generally, most applications can see quite a gain from a caching implementation. And lastly, on the caching tier, we have third-party providers. We are partnered with a couple vendors that have provided solutions for dynamically scaling this memcache or caching tier, and we can talk to you guys and hook you up with them if that's a solution that you want to go forward with. Okay.
So let's take a quick pause here before plowing through the rest of the reference architecture, Brian. One thing I wanted to mention: we've had quite a few questions come in on the load balancing part of the tier. And just wanted to mention that please take a look at the white paper that Brian referenced earlier. It's up on our website, pretty easy to get to. And it is a very, very detailed technical treatment of 3 different load balancing solutions. It goes into detail about the testing methodology used, the performance, the pros and cons, and the appropriateness of each solution to different use cases. So please have a look at that because there's a lot of detail in there that covers many of the questions that were given to us. I also wanted to mention before we dive into the next tier that this basic reference architecture that Brian's been running through is not really just theoretical. It's been heavily tested in real production websites, including many of the big poster child stories in the cloud that some of you may have heard of before. This kind of architecture helped support a branding site for a bricks and mortar company that went from 0 to 35 million active users, individual users in a single morning. It supported another company that had dropped 4.5 million catalogs in the postal service and then found out from load testing that their website was not going to handle the load. It was done on an internal implementation. And many, many other real-life stories. In fact, one of the most fun things about working at RightScale is the variety and I would say the colorful nature of the different applications that we see. This kind of architecture supported a scale from 50 servers to 3,500 servers over 3.5 days a couple years ago. So it's very much battle tested. That said, let's go ahead and move on to the database tier. My comment here would be, for most of our customers, it is the most critical tier in a way. It's the most tricky tier, and many people come into us trying to figure out what's the right solution because, should I use a relational database? Should I stick with something like MySQL or another relational product? There are all these ancillary caching solutions, and then there are no SQL solutions out there. So could you take us through that a little bit, Brian?
Sure, absolutely. And as Michael said, there's a lot of architectural options out there for the database, and as we've mentioned, no one size fits all. So always test, run your benchmarks, run your load tests, try to figure out what's optimal for your particular environment, and that can change over time. And we'll see here in a minute that RightScale has the tools available to help you with those changes as they come up. Well, our tried and true is good old master and slave configuration, typically MySQL master and slave. So we always recommend to use multiple slaves if your budget permits. And again, the common theme you've heard is distribute those across availability zones. Availability zones, it's not frequent they go down. Can they go down? Yes, right? But you want to always be able to prepare for the possibility, not something that will happen but may happen. The other thing that customers often ask us about is to say, okay, I'm using this slave database and I'm just using it as a replicant. I'm just using it there as sort of my backup. Does it need to be the same size? I'm using an M2 XXL. It's costing me $1.60 an hour. Can I get away with an M1 large, which is the 64-bit OS, and I'm going to save like over $1 an hour if I use this one? Well, we always recommend you use the same instance size, and the reason being that you probably chose that M2 XXL for a reason. It was big enough to handle what you needed it to handle. And in the case where maybe that master goes down, you now need to promote a slave to take over that master role. Well, now you're promoting an underpowered and unprepared slave, and you can have the exact same problem that you use that larger master to solve in the first place. So yes, it does cost more, but we always recommend using that same instance size for the master and all of your slaves. Data storage that the database uses. We always recommend you use EBS volumes or whatever your cloud's analog is for that data store. Never use the ephemeral storage for persistent data. If that server goes away, if that instance dies for whatever reason, that storage goes away. Obviously, back up your master and your slave frequently. The RightScale tools out of the box will back up the master every 4 hours, and I believe the slave every hour, although those are customer configurable as well. And we always recommend, and our tools do this by default, is to upload those snapshots, those database snapshots, to S3 or some other persistent redundant storage. So that if you do have any sort of catastrophic outage, you have the ability to get back the most recent database backup. Instance size. You've heard us mention M1 large as sort of good building blocks as we've gone through. This is where there is no good one-size-fits-all solution. It really varies greatly based on your application and the type of traffic that your application is going to see. We, again, always recommend you do load testing and benchmarking and find out what that optimal starting size for your database is. And we have and we'll see here in a moment, the ability to kind of, if that size doesn't turn out to be appropriate as you grow, we have the tools in place to help you with that. A lot of our customers in the last couple months, 6 months, 8 months or so, have started to ask us about RDS, Amazon's relational database service. Similar to an ELB, as we talked about earlier, it's an appliance. It's a database appliance, and it has the same caveats. You don't have access to that instance. You can't SSH in and look at the CPU utilization. You can't look at the slow query logs. You can't run top on the box, those kinds of things. So if those aren't important to you and you don't care and you just want to have an appliance out there that does its thing, it can be a very viable solution. It does require scheduled downtime, but what Amazon announced a few months ago was multi-availability zone functionality. And what that allows you to do is you can basically replicate, if you will, your RDS instance in 2 availability zones. And when you have scheduled downtime on your primary, I believe they call it, they will automatically fail over to the secondary. So your application never has to have downtime. Before the multi-AZ functionality, you had to have up to 4 hours a week where your database was unavailable. And obviously for production environments, that wasn't sufficient. But now that the multi-AZ functionality has been released, it's become a much more viable solution. And then in October of this year, they announced read replicas, which you can kind of think of as the additional read slaves if you're familiar with the MySQL type solution. Okay, now we're going to talk about scaling. And this is sort of the holy grail of applications, is how do I scale my database, particularly in a horizontal direction? And let's talk a little bit about both vertical and horizontal here in the next couple of minutes. Vertical is basically to grow or shrink. Obviously, we hope you're growing. That means things are going well. Grow or shrink your database server from one instance size to another. And RightScale has the tools in the platform that allow you to do that. If this M1 large turns out not to be sufficient, we have the tools that allow you to grow that to an M1 extra large, or an M2 double XL, or whatever instance size you may need with virtually no downtime. The other is horizontal, and that's where you add additional servers to help spread that database load. And we'll talk about both of these here. Here's a pictorial representation of vertical versus horizontal. So in the lower left, you see the initial case. We've got this small type A and a small type B. Well, in vertical scaling, you basically have the same number of servers, they're just bigger. Whereas in horizontal scaling, which you see there on the lower right, you have more servers of the same original size. Okay? And that's the basic concept between vertical and horizontal scaling. All right, horizontal. The most common one is the addition of read slaves, and this is obviously effective for read-intensive applications. You can spread that read load. Only the writes need to go to the master, and the only problem can be is that replication lag to these slaves. You have to consider that at all times. If your application is, for whatever reason, may write to a data object and then very rapidly read from that exact same data object, you're not using caching, for example, that can be a problem. So you need to factor that into your application design. A very effective mechanism to do this is something like MySQL Proxy for those who get familiar with it. And the concept here is, as this picture shows, is that the app servers talk to the MySQL Proxy server instead of to the master directly. And the MySQL Proxy sends all of the writes to the master, and all of the reads get round-robined, if you will, load balance out to the slaves. What isn't shown in this picture is that all those slaves are replicating from the master as well. I didn't draw in all those extra lines. It would have looked too busy, but the same concept is still in play. Now, while this is a good pictorial representation of MySQL Proxy, it's not the exact implementation that we recommend. What you see here is that MySQL Proxy server is a single point of failure. If that was to go down, you would not have access to your database. So instead, what we always recommend our customers do is install the MySQL client on each of the application servers. And therefore, each of those application servers, instead of talking to an external server, talks to localhost on port 3306, which is the MySQL port, and the MySQL Proxy client is listening there, and he's aware of where the master is and where all the slaves are. So that proxying takes place locally, if you will, and that removes that single point of failure. But it doesn't make as nice and pretty a picture, so I use this one instead. Another option for horizontal database scaling is sharding. And the concept here is really to slice your database, right? Partition it into distinct, non-overlapping pieces. It's what they call a shared nothing architecture. Your entire database is cut up and spread across multiple servers. However, forethought is required here because setting up these shards correctly really takes a little bit of a forethought, because if you do any sort of cross-shard joins, that can be very resource intensive. You're going across the network, you're hitting multiple instances, etc. And pictorially, what this looks like is this, is you have app server, and this just shown a single app server here, but obviously it could be multiple app servers, hitting a single master database with customer records with their last names A through Z. So here's your before sharding concept. And after sharding, you have that same app server, and it's basically those master DBs, A through E, F through M. Each of those has a portion of the original database, and those 4 master DBs you see there can logically be thought of as one single master DB, but they're sharing that load, both in the read and the write, and that obviously helps prolong the livelihood of your database. Now, I should also mention, as far as sharding is concerned, we have a technology partner that has helped a lot of our customers with database sharding, and if you guys are interested in that, we can definitely hook you up with them. And we've had a lot of great success with the database sharding concept. No horizontal database scaling discussion will be complete with master-master. And as the name implies, there's 2 or more master databases involved. The difference here between the master and slave is that any master can modify any database object. Now, obviously, replication lag is a problem there, but also poorly designed applications can cause problems there as well. You can get data object collisions, and you can leave your databases in a state where one of them is right and one of them is wrong, but you don't know which is which. And therefore, it's not a recommended best practice, and it's not supported by RightScale. But we do mention it because some of our customers have implemented it on their own with some with success and some very limited use cases. And in the last couple months, we've seen a very, very a great increase in the request about NoSQL solutions. And there's many options out there, and I've listed a few of them here: Cassandra, Membase, CouchDB, etc. As opposed to a SQL or a relational database store, it's basically a key value store. And what that means is that instead of being able to do relational requests, you can't say select star from table A where attribute B equals value C. You basically say, give me whatever is at location 42. And if your application lends itself to that type of architecture, it can be a great solution. It's a very fast and efficient solution for basic key value store type operations. Multiple nodes are used to implement that data store. However, coordinated backup and recovery can be challenging if need be. Certain applications may not need it, but if you do, that can be the most challenging part of a distributed NoSQL solution. Some of our customers are beginning to use these NoSQL solutions in very specific use cases, and again, are starting to see some great benefit involved. So, what's best? Well, as typical in many technology discussions, and you've heard us say many times today, well, it depends, right? Many scalable environments share a lot of these common underlying architectural concepts that you've seen today, but every application is different. And as such, there really is no one-size-fits-all solution. But RightScale has a lot of components pre-built that can assist you in building your scalable web applications.
Right, let me just add in here, really what we've done since day one is offer a fast on-ramp for customers. And so what you see in this diagram is the ability for you as a customer to come in and RightScale to offer you from this entire collection of pre-built components. This would be everything from individual server templates to special scripts that we've written to collections of server templates. We call them deployments. They're clusters that are meant to operate together, and server templates that are meant to interoperate with other server templates in kind of a plug-and-play Lego block kind of manner. So you can see here that we have quite a wide range of solutions across operating systems, programming languages, and their accompanying application servers, different database solutions, web servers, load balancing, as well as approaches to scripting and automation and automatic configuration. So really this represents a whole collection that gives you a fast on-ramp, and RightScale is there with these to begin with. I think we've done a study and more than 3/4 of our customers end up customizing the solutions that we provide. So you shouldn't think of these as kind of unchangeable binaries, but rather very open source code, at least in the form of down to the script level, that you can customize, tweak if you need to for whatever your particular project is. And then, of course, our services department has people like Brian and others with a lot of experience in helping folks to move to the cloud. So with that, I think we're going to move right into the Q&A session here. We've gotten quite a lot of questions in, and interesting ones too. So Brian, you want to pick one and let's dive in there. Sure.
I spent the last minute or so while Michael was talking sort of organizing them in tier by tier, if you will, so I might be able to knock off a few of these at once. So the first question was regarding the load balancing solution. How does HA Proxy and Apache handle SSL termination? And basically the gist there is that you have Apache there, it's handling the SSL termination. So incoming requests on 443 are handled by Apache. The SSL is terminated by Apache at that point and then forwarded on to HA Proxy, which is listening on, by default it's 85, but it can be configured to whatever you want it to be. HA Proxy then picks up that unencrypted connection and passes it on, load balances it on to the back-end web servers. More load balancing questions, and I think these two are sort of very much related, or I can answer them in one. So let me read both of these here, and then I'll go ahead and give an answer that I hope will address both of them. So the first question was, how do the load balancers in multiple AZs affect the response time of the back-end app servers? Basically a question about latency, I suppose. And the second question, which I believe is related, is how do you handle the latency of distributed tiers in the cloud? Since the reference architecture is not connected in a single data center, and that is true, the different AZs are in different data centers, there isn't any high bandwidth connectivity between app tier and DB tier. Can this be addressed? There actually is high bandwidth connectivity between the tiers, particularly in AWS's EC2 infrastructure. We've run some tests. I don't think we've published them yet, actually. I've done just some basic traceroute and ping type tests, but all of the Amazon availability zones within a region are fiber connected behind the scenes. So within an availability zone, we've seen ping times of 500 microseconds, And across AZs, we've seen 1 millisecond. So 1 millisecond round-trip ping time is pretty quick, even between data centers. So you're correct. They are not the same data center, but there is very, very little latency between them.
Great. Thanks, Brian. So I'll take a question here. The question is, can you compare and contrast RightScale versus platform-as-a-service solutions like Heroku for Ruby on Rails projects? And my comments will really apply to any platform-as-a-service solution. So in general, there's not a better or worse here. As Brian mentioned before, it depends on your needs. You can see in this matrix that we do support Ruby on Rails. In fact, that's a language that's heavily used at RightScale internally, so we're quite familiar with it. I would say, as a general comment, if your application is fairly straightforward and simple, and it's served well by the notion of just pointing a platform-as-a-service solution at your code repository, and everything else is handled for you, and that works for you, then I think great. You can use something like Heroku or other solutions, Google App Engine for other languages, etc. What we've found among the customer base is lots of people coming to us who have some more complexity in the overall deployment, the overall set of services that they need to run. And that's where a matrix like this is very favorable, because you can get in there not only across these 6 areas that we've highlighted here, but really any level of the stack from the OS right on up. And you can make tweaks, you can make customizations, you can do special optimizations in the architecture and the design. So I would say as a generalization that those who have simpler apps tend to go for the platform as a service offerings, and those with, I'd say, more mature or complex apps, any kind of complexity or a need to drill down, get into the details and customize, or also get into the details of how the app is performing with very detailed monitoring, would be benefited by a platform like RightScale.
Great. We have another question here. This is on the app server tier. Is code deployment on server arrays done via the RightScale API or some other construct? And the answer is yes and yes. You can do it via the RightScale API. The RightScale API has the ability to run any script across an array of servers. But you can also do it within the RightScale dashboard itself. In the user interface, there is the ability to basically set up via a single button click. You can go ahead and run a script across all the servers of an array. So yes, both via the API and via the user interface manually.
Thanks, Brian. Okay, next question. Is most of this specific to Amazon? What about the Rackspace Cloud? So most of it is not specific to Amazon except where called out by Brian. So in fact, to add one comment there, if you're using something like ELB, the Elastic Load Balancing Service from AWS, or RDS, the Relational Database Service, those are completely specific to Amazon. And in fact, one of the choices you would be making there is to be adopting a service that is pretty specific to Amazon. So if you look to move later on, there would be more work involved. And it depends on exactly how you use it, how much work would be involved. But that's one of the trade-offs involved there. If you're happy to continue on Amazon and you don't foresee the need to move, that's not an issue. So we do support Rackspace Cloud with much of this. I think it's fair to say probably the support on Amazon among these varieties of solutions is more complete because it's been out there longer. But at the end of the day, again, it gets back to the it depends. Best way is to give us a call, tell us what you're seeking to do, and our account managers will work with you and even get some scoping done with the services department to get you an answer on what's appropriate to run where. We're very much oriented around making you successful, and so we're not going to point you in a direction that ultimately won't work.
Great, thanks, Michael. And another question we have here on the caching tier. Can you auto-scale the caching tier? If yes, do you automatically restart each app or app server so that it knows of the updated set of memcached resources? And the answer is yes, you can auto-scale the caching tier, but it's not a recommended best practice for kind of the reason that you mentioned here in the question, and another one as well that I'll touch on is that if you do dynamically auto-scale that memcache tier, each application server does need to know about that new memcache server, and therefore it does require a restart, which will effectively reload the list of memcache resources. But the sort of the worst part of that as well is that on the database side, I liken it to a card game where the database is the dealer and all of the memcache servers are the players. And in this particular game, you deal out the entire deck. And every time a new player comes in, you got to sweep up the deck and redistribute it. So when that new player, that new memcache server comes into the mix, well, now the database is going to get some performance degradation as he sweeps up those cards and redistributes them to all the new players in the game. So yes, you can auto-scale it. It's not a recommended best practice, but that's where some of our partners, for example, the folks like at Membase and some other similar organizations are coming out with the ability to dynamically scale that tier, which eliminates the need to do the restart on the application, as well as eliminates the need to hammer on the databases, if you will, because that coordination is done amongst all the nodes within the tier without a need to go back down to the database to pull things out.
Great, great. Here's another question, kind of touching on the another Amazon service called MapReduce. Do you support Amazon MapReduce? Certainly possible to use Amazon MapReduce, yes, from the RightScale infrastructure. We don't have a pre-built solution in this list around MapReduce, so there would be some direct coding work involved or direct configuration work, but that's part of the openness of the RightScale platform. You absolutely can use any service. In fact, at our last user conference, we had some customers, back to the platform as a service question, some of our customers are actually using split deployments between RightScale running on an infrastructure cloud and some platform as a service offerings, notably Microsoft Azure and Google App Engine. And they've put different parts of their service in different solutions or infrastructures for different reasons. Another question about which cloud platforms do we support. So just to add to Rackspace, which is another supported public cloud platform, wanted to mention that we've been working hard to add support for so-called private cloud solutions, and specifically Eucalyptus and Cloud.com's open source private cloud solutions. And we have partnerships with both those companies, and cloud kits available, which involve a combination of a startup reference architectures that we recommend in terms of hardware characteristics that you might deploy an internal cloud on, as well as consulting services, etc. So RightScale, in terms of its multi-cloud support, now spans both public clouds and private cloud infrastructures.
Another question on the caching tier. The question is it poor architecture to cache small, infrequently changing data on each app server individually instead of setting up dedicated caching servers? It depends. Unfortunately, the answer is always it depends, right? So if you're caching just a few objects and you have just a few application servers, probably not that big a deal. The only caveat there is, let's say you have an auto-scaling tier that may grow into tens, 20s, hundreds, something like that, and you're caching the same object. Well, that means if you have 100 application servers, that you may have needed to hit the database 100 times to pull out that single data object. Whereas if you use a dedicated caching tier, you only hit the database once for that particular object. Now, again, it depends on the lay of the land, if you will, on how your application is architected, how often you need to access that particular database object, and how many application servers you're going to have in the array. But if cost and budget and resources permit, we do recommend the dedicated caching tier. But as I said earlier, a lot of our customers have used the co-resident caching, if you will, with Memcache resident with the application server, to great effect as well in those certain use cases.
So here's one around security and overlay networks, Brian, and I'm going to pose it to you. What is your view on overlay networks and VPCs? I think that's referring to Amazon's virtual private cloud offering. Would you say it's necessary from a security perspective?
Not necessarily. It depends on obviously the rules and regulations of your particular environment. The use of security groups, that's obviously an EC2 security group, but there's also similar concepts in both Eucalyptus and Cloud.com, as well as something similar in the Rackspace Cloud as well. Through the judicious use of those security groups, you can really limit the traffic, and basically it allows you to open and close ports to restrict, I should say, port access to specific IP addresses. So if that's sufficient to meet your needs, it's great. If not, the VPC is a very viable solution. The only caveat thus far with the VPC solution is that you have to have that on-premise router, that BGP-enabled router that speaks iOS 12.4 or higher or whatever their current recommendations are. But all of your traffic from your cloud instances, that external traffic, the cloud instances hitting the internet, goes through that on-premise infrastructure. So if your cloud instances in the VPC don't need to talk to the internet, it can be a great solution. If they're going to be very chatty with the internet, all that traffic is going to go through your on-premise infrastructure, and you need to make sure that you keep that in account as well. Now, one last point on there also is that some of our customers have used some VPN solutions to great effect, things like OpenVPN and VPN Cubed, and that allows you to basically wrap any on-premise servers you may have into a VPN with one or more of the cloud-based instances. So again, depending on the architectural needs and the application needs and the corporate needs, if you will, from your security group, there's usually a solution that we can find, and we'd be glad to talk to you all about that and try to find the right solution.
Excellent. Here's another security question. Are there solutions you have provided that have been security approved from an infrastructure or implementation perspective, for example, PCI compliance? So I'll take that one. We have helped companies implement PCI compliant solutions, HIPAA compliant solutions, etc. And it's interesting, about 2 years ago I used to answer people that I thought this space would evolve in the cloud, and indeed it has. So after the last 2 years, if you look at different cloud providers, I think Rackspace has had a number of regulatory compliance offerings in terms of PCI, HIPAA, and SAS 70, etc. And we've also seen that with Amazon. Over the last couple of years, they got SAS 70. They offer HIPAA compliance. They just, I think in the last week or two, announced PCI Level 1 compliance also. So the devil is always in the details around security, and it's always a multi-layered question. So please give us a call, and we're happy to walk through what we can do there and how we can help you. And in addition, we have a webinar in our library that we co-hosted with Amazon Web Services around, and a gentleman named Steve Riley, who's their security expert, around security and how to approach that in the cloud.
Great. Another question here on sort of auto-scaling and the load balancer and application tier connection is, it says, how would you suggest connecting a server from an auto-scale array into HA proxy, i.e. registering servers into its config files? Well, the nice thing is that the RightScale platform takes care of all that for you. The auto-scaling implementation that we have, if you will, one of the write scripts that we have is we have a connect with HA proxy and a disconnect with HA proxy script, and equivalently a connect with ELB and a disconnect with ELB. And basically the last phase of the boot process of an application server in an auto-scaling array, this app server spins up, and the last thing it does after it's dropped all the code in place and it's basically ready to go is that it will then dial in, if you will, to the HA proxy box and automatically register itself and say, hey, I'm here and I'm available to start handling traffic. And in a scale down event, similar things happen. The last thing it does before it dies is it dials into that HA proxy or ELB and says, hey, take me out of the mix, I'm going down, and automatically removes itself from that load balancing pool. So that's all handled automatically from the RightScale platform is the short version.
Great. I think we're coming to the end of the hour. We do have time for one or two more live questions, but before we go into those and finish up, just wanted to give you this reference slide. If you do have a project, I think over 70% of you said you're working on a project now and you'd like to consult with us about potential of moving in the cloud or leveraging RightScale to help you manage it. Give us a call. There's the information right there. We also have a free edition that you're welcome to sign up for at any time. Register cloud credentials with the free edition, and it's limited in functionality, but there's quite a bit there. If you'd like a taste of the fully paid edition, we offer something that we call a VIP trial, which we can arrange also. And then, as I mentioned, we have a ton of content available. We do have the Scalable Web App white paper coming soon. We're going to automatically mail that out to everyone who's attended this webinar, so you'll get a copy of that. And then we have other white papers available also on the site, as well as a host of other information from a knowledge base and support point of view and how-to information there. So with that, do we have a couple more questions and then wrap up, Brian?
Sure. We've got another one here, right? Again, on the proxy, sort of the front end type thing. It says, can you elaborate a bit on how a proxy can be used without relying on a single point of failure? And this, I'll answer this sort of twofold. One is from the HA proxy solution side, and the second is from the ELB side. Is that, as we mentioned in the load balancing tier discussion, we always recommend you use at least a minimum of 2 HA proxy boxes up front. Even if your traffic, you know it'll never go above that 5,000 responses per second need that I had discussed that an M1 large is capable of handling. We always recommend you use a minimum of 2 to eliminate that single point of failure. And again, we recommend that you spread those across availability zones within the region. So if that particular availability zone suffers an outage, whatever it may be, that you have not lost all of your capabilities, if you will, to serve your traffic. Now on the ELB side of the things, the ELB is handled on a per region basis. You create one in the region, so in the cloud, in the US East or the US West, whatever it may be. And really behind the scenes, if you do a little bit of digging, you'll see that that ELB is implemented via multiple, I don't know the exact details, but it's pretty obvious. It looks like it's multiple instances that are handling that traffic for you as well. So you never get just one instance behind the scenes handling your traffic. So if there is some sort of failure, you have not lost all your capacity. So by judiciously using HA proxy or using ELB, you've kind of have eliminated that potential single point of failure.
Cool. Thanks, Brian, and thanks, Michael, and thanks, everyone, for joining us. This webinar has been recorded, and we just need to process it once this GoToWebinar is over, and we will send it out to you within the next day or so. You can also find it on our website at rightscale.com/webinars. We're actually going to keep the webinar functionality open for a couple more minutes. If you have any more questions, feel free to send them in via the GoToWebinar questions panel. Jared will be continuing to answer those for you, and we'll stay on as long as you need. Otherwise, thanks again for joining us. We hope that you have enjoyed this presentation.